Hi, my name is Sean Doyle, and I'm from FIRST Robotics Competition Team 4905. This is my first video in a multi-part video series entitled Introduction to Programming for FRC Robots, and my intent for this series is to give a general overview of how we run our software on Team 4905, and then later on go more in depth in topics that I cover earlier on. So in this video, I'm just going to touch on a lot of general topics and trying to give a kind of crash course in software and how we run our software on Team 4905. And then later on in later videos, like I said, I'll go way more in depth in a lot of the topics that I talk about today. So the first thing I want to talk about is the hardware that's involved with writing and testing software. So you need a laptop in order to write software, but the other two pieces of hardware I want to focus in on are this radio here and the RoboRio. So the RoboRio is the real brains of the operation. That's where the code lives when it's on the robot, and that's what runs the code when code is on the robot. But in order to get code to this RoboRio, you typically pass through this radio here. Now, a radio is required for every FRC robot in order for the field to actually communicate with the robot, in order for you to run the robot during competition without a wire while playing a match. But it also allows for you to connect to the RoboRio over Wi-Fi. So if you see this pathway here, you can send code from your computer to the radio over Wi-Fi and then through an Ethernet cable to the RoboRio. Your radio will be connected via an Ethernet cable to the RoboRio. There are a couple other pathways that you can also pick in order to send code to the RoboRio. So you can also hardwire your laptop into the RoboRio with this above pathway here. What that allows for and what that's useful for is during competition, your Wi-Fi and your radio has to be disabled because that's how the field communicates with the radio, and there has to be a special protocol that it uses and special setup. So typically at competition, you would use an Ethernet cable to directly connect to the radio, which then would send your code to the RoboRio. Or if you think that your radio is giving problems, oftentimes you'll see programmers use a USB cable down here and follow this below pathway where they send code from their laptop through directly to the RoboRio using just a USB cable. It should be noted that these pathways just refer to the way code is sent from the laptop to the RoboRio, and that when the robot's actually running, all the processing is happening on the RoboRio itself with very little information being sent back to the laptop. So this just refers to writing code on the laptop and then sending it to the RoboRio. That's all this diagram is for. So what do I mean by code, and what should you be picturing when I talk about code or a program? So what most people picture, and this is a perfectly fine picture, is the image that I have in the center. And this shows an integrated development environment, which is just a fancy way of saying a place to write code and edit code. And so you'll see, different files up here and different lines of code here. And now what code for at least our team is written in is a language called Java. So there are plenty of different languages of code, just like there are different languages that people speak. And all that means is that there are different ways of saying the same thing through code. So the way we choose to speak is in this language called Java, and that's the language that we write in to program our robots on Team 4905. Now, the other image I have here is a WPI-lib symbol. So we don't write all of the code for our robot from scratch. We have a library that WPI, the college, provides for us that allows us to easily jump into the season and write code much more quickly than before. So WPI-lib provides us with a lot of the base and superstructure for writing code, and then we fill in the details with the specific implementation of how our robot works within the code. So we just use WPI-lib as the base to start off of. So now I'm going to talk about really what's happening on the RoboRio when our code's running. So the important thing that I'm going to talk about here is called the scheduler. Now this is something that WPI-lib provides for us. This is something that pretty much it's run every 20 milliseconds, or the scheduler determines what's run at what time. So every 20 milliseconds, there's one loop of the scheduler here, okay? And it goes through and checks to see what should be running at all times and then runs things that should be running. So I have some commands here. So I'm going to definitely talk about commands a lot more in later episodes, but basically you can think of commands as just things that the robot can do. So the robot can extend an arm, it can drive forward, it can retract the arm, it can do autonomous mode 13, and it can drive backwards. Those are the 5 commands I have here. So let's say, for example, the user presses this yellow button here, right? So when that yellow button is pressed, as the scheduler is going through, it realizes that the yellow button is pressed, and it knows that the yellow button corresponds to extend arm. So extend arm gets put on the scheduler, and every 20 milliseconds, it's going to be running extend arm. Okay, so now let's say the user, presses the red button. The scheduler knows that the red button corresponds to drive forward, and so it puts drive forward on the scheduler. And so now every 20 milliseconds, it will run extend arm and then drive forward. So these are all the types of things that we program in. We say yellow button pressed, extend arm, red button pressed, drive forward, and then the scheduler reads that from the program and it knows what to do. Now let's say that the blue button's pressed, and that corresponds to retract arm. So we would put retract arm, but as you can see, something happened. Extend arm got kicked off the scheduler and put back into the commands kind of lobby, I guess you can think of it down here. That's because the scheduler is smart enough to know when commands conflict with each other. Retract arm and extend arm use the same arm subsystem, so they can't be run at the same time. The scheduler knows that, is able to cancel the extend arm when the blue button's pressed, and just puts retract arm onto the scheduler. So now every time through, we'll run drive forward and then retract arm. And now over time, these commands will each finish. Drive forward will finish after the command says it's done, and then retract arm will finish after retract arm says it's done. So that's a basic overview of pretty much what's happening on the robot, on the RoboRio, when the robot's being run around. Let me just be clear with how the scheduler works. Let's say when there are two commands on the scheduler, these commands will be run at the same time. Every 20 milliseconds, one execution of drive forward will happen, and then one execution of retract arm will happen after it. So these can really be thought of as happening at the exact same time, these two commands. Next thing I want to talk about is driver station and smart dashboard. So of the above image here is what's called driver station. This is provided by WPILib, as is smart dashboard. And driver station is really how you enable and disable the robot when you're trying to run it. So there's an enable button here, disable button here. There's some modes you can set in: teleop for using joysticks to control the robot, autonomous mode if you want to test your autonomous routines, practice mode to simulate a match, and test mode to get data back from sensors more easily. And then there are some useful things over here. It shows the voltage on the battery. It shows whether you're communicating with the RoboRio and whether the RoboRio has robot code that's not crashing. This will be red if the robot code is crashing, and whether you have joysticks connected. As you can see here, there's a little message that says no robot code. That's because it's red for robot code. And then the other thing that's very useful about driver station is that if you press spacebar, that emergency stops the robot. In case something goes wrong, you can stop the robot that way. What's down here, this is smart dashboard. Smart dashboard is really just a useful tool for getting data back from the robot and even sending data to the robot. As you can see on this smart dashboard, it shows some sensor readings, input voltage, total current, temperature. You can put pretty much anything you want on smart dashboard and get any data you want back from the robot. You just have to code it up. You can even put cameras on here. That's most likely what this is. Maybe the camera's unplugged. That's why it says no connection. But if there were a camera plugged in, you would be able to pull it up on Smart Dashboard. And you could even set commands to run from Smart Dashboard, where you can set up a command and then you can press like start for the command and it will run. And that's very useful when you don't want to use a clunky joystick in order to run commands. So the last thing that I want to talk about is GitHub, which is the type of source control that we use on our team. Source control is just a fancy way of saying how programmers work together in order so that the same programmers can be working on the same set of code, but then it can all come together in the end. So GitHub is really useful in that it allows us to switch between different types of code, different code with different features that are implemented at different times, and even go back in time to previous sets of code that was working previously when we have problems. So what I have here, an image on the right here, is an image of GitKraken, which is an interface for GitHub, which just shows all these branches on the left here and shows some commit messages. A commit is just when you want to save away the changes that you made, that you make a commit. So this is just an interface for viewing GitHub and for viewing changes made on different branches. So just going to zoom in here. So a branch is made, I should specify, a branch is made every time you want to add a new feature to a set of code. So you can see new auto modes here. That's not the best branch name because it doesn't really specify what auto modes are being added, but you know from this name that this branch has newer auto modes, that if you want to work on auto modes, you might want to look at this branch or even branch off of this branch. The branch I want to focus in on here on this zoom in is master though. Master is the one branch, the branch that's definitely working, that has the working code on it. So at any given time, master should be working and only code that's working should get onto master. So that's how software developers and developers on our team structure using Git, in that master is a single branch that always should be working and always has working code on it. What I have over here, these are just commit messages. Every time you commit, which is just pretty much a save, that's what you can think of it as, you have to say a message with what you did. Auto code that only deploys the intake when it feels like it. Yeah, so it looks like auto mode still has some work to do according to this commit message. So that concludes the first video. I hope you found this helpful, giving a general overview of how we run our software on Team 4905. I know I covered a lot in this video, so feel free to go back and rewatch parts of it if you didn't get it or didn't get it fully. But like I said, I'll be going far more in depth into a lot of the things I talked about here. This was just a general overview for anyone to get an understanding of what they should be thinking about when they hear software or programming. Thanks for watching.